I'm going to be presenting on Git. Now, this is actually an advanced talk. If you're unfamiliar with Git entirely, there may be some concepts in here that are a little foreign to you, and so I would encourage you to take some time after the conference and beef up on those basic skills. I'll cover some basic things, but we're really going to go much deeper in this particular talk. On the screen there, you've got my Twitter handle and the link to these slides. So feel free to grab that link. You can follow along, or you can watch the presentation here. But that link is up, and you can actually refer to these slides after the fact. There are some code examples and such in there, so you can get all that information after the conference if you need to follow up on those topics. As Ralph already mentioned, I do work for Append2. Senior JavaScript engineer. I'm also a team lead here, and I've been working in Git for quite a while. So this is a topic that we're fairly familiar with, both at Append2 and me personally. I want to talk about what we're going to talk about. So first of all, we're going to do a little bit of a review, and I know this is, as I mentioned, an advanced talk, but we are going to talk a little bit about the basics. In particular, we'll talk about how Git is distributed, about how it uses snapshots over file diffs. We'll talk about staging and committing, as well as about just general branching. We're not going to go really deep into too much of the basics of staging and committing, but we're going to talk a whole lot about the various aspects to it. When things go wrong, so just, that's a lot of what Advanced Git is about, is when things are not playing nicely with what you're trying to do. So amending commits, resetting, stashing, using the log and blame, and just generally a lot of the other things that come involved with trying to make Git do what you need to do when something has gone wrong. The last section is playing nice with others, and we'll talk a lot about merging versus rebasing. We'll cover cherry picking and tags, talk about remotes, and at the end I'll briefly cover pull requests and kind of the open source model for Git. So let's jump right in with a little bit of a review. The first thing that I just want to talk about is how Git is distributed, and this is something that a lot of people hear about, but they don't really understand kind of what that means, because most of us use Git with something like GitHub or TFS or Bitbucket or whatever you're using, and when you use it in that way, it doesn't appear very distributed, but it actually is entirely distributed system. And what that means is everyone that has a repository, a Git repository on their local system, has the entire repository. They have everything that has happened in that repository up to the point at which they clone the repository to their local system. Now, if GitHub or Bitbucket or whatever also has a version of that repository, that's great, but that is just one version in a distributed environment. You have another version. Your friend John might also have a version. And that central repository that we use typically with GitHub and Bitbucket is not actually required. If those systems go down, I have all of the branches that existed from the last time I pulled from GitHub. I have all of the commit history, and I could then actually set up a connection with my friend John, and we could just work together without the need for this centralized server. So that's kind of what it means for Git to be distributed, is that you have everything you need in order to work with other people and manage those versions. So that's the nature of it being a distributed environment. Additionally, one of the big differences between Git and some other version control systems is that it uses snapshots versus file diffs. And what that kind of means is that each snapshot is, each commit is a snapshot of the entire repository at that moment in time. So let's look first at what file diffs look like. So in this image, you can see how this is, I believe, it's a very generic image, but you can kind of compare this to maybe what Subversion does. What you have is each file being tracked individually with different versions of that file. So you've got changes for each file, and they're being tracked horizontally across the files. In comparison to that, snapshots are taken of the entire repository. So you have 3 files, A, B, and C, and you have version 1, so let's call that a commit in Git. The snapshot, the commit itself, is the entire repository at that point in time. You see version 2 and 3 and 4 and 5. Each of those commits is a snapshot of the entire repository. And so even though in the diagram file B doesn't change in version 2 and 3, the commit hash is still the entire, the commit is still a hash of the entire repository. It's a snapshot of that entire repository. And that's going to become really important when we talk about data integrity, and I'm actually going to mention that a little bit later, so we'll talk about that. I want to talk a little bit about staging and commits, and again, this is a little bit more of a recap. I'm not going to start from the basics there. There it is. So first of all, I just want to point out Git status. I mean, a lot of you have probably used Git status if you used Git at all before, but Git status is your friend. I would highly encourage you to really understand everything that comes up in Git status in that information dialog and really understand what's going on there. So if you just do Git status just in a clean repository, you'll see that you're on branch master and that there's nothing to commit and that the working directory is clean. So it's actually showing you 3 different pieces of information there, that what branch you're on, that branch has nothing to commit, so there's nothing in the staging area, and there's nothing changed in the working directory, though all 3 of those areas. So very important to understand what all of those pieces mean. So let's say we add a file. So we're going to do touch readme, and that just creates a new file. And when we do git status, you can see we're still on the branch master, but now we've got some untracked files, just one untracked file. And it tells you what that file is and also gives you a bunch of other information about how you can move that file into the staging area and that there's nothing to be committed, but that you have untracked things. So an untracked file is something where Git knows that it's there, but it doesn't have any record of it otherwise. It can see it, but there's no history of it otherwise. When we do git add, we're staging that file. So we move that file from our working directory into our staging area, and that staging area is where we're able to then commit the file. So when we do git status after an add, you can see that we've got changes to commit. And it tells us how to unstage those, which we'll get to a little bit later. You, of course, commit it. You do git commit, and I do -m to add a message. Now, I want to point out at this stage that we're using the command line here, and we're going to be using it the entire time. And most of that is because some of the advanced features in Git are very difficult to use in the graphical environment and look very different from one GUI to another GUI. And I don't want to start getting in the habit of showing you one GUI and then you try and use a different tool, and it looks entirely different, and you have no way of understanding what's going on. So we're going to be using the CLI for everything today, so I just want to point that out. You can see that once we do a commit, you actually get some interesting information, like the commit hash and what changed and such. This is just a brief diagram, a very common diagram you've probably seen before of what has happened. So when you check out a branch, you pull that branch out of the head of the repository. So blue is your repository. That kind of yellowish-orange is your staging area, and then the green is your working directory. So we pull those changes into our working directory. We make some changes in our working directory, and then we're going to stage those files. So we move it from the working directory on the right side of the screen to the middle area, the staging area, and then from there we do a commit, which puts those changes into the actual repository. So those are the 3 different areas of your Git repository. There's the repository, then there's your staging area, and then there's your working directory. And so those are the repository is your branch. It's synonymous there in this case. I do want to talk about commit hashes, and I kind of mentioned this a little bit before, and a lot of people know, oh, I've got a commit, it's got a hash, and they know that there are hashes, but a lot of people don't understand exactly what the hash is. If you recall when we were talking about snapshots and how Git uses snapshots instead of file diffs, the commit hash, the hash that you see here in bold, B9, BD0, B02, that hash is, first of all, that's a short version, and here's the longer version in our Git log. That hash is an actual SHA-1 hash of everything in the repository at that point in time. And that's really important because if anything changes in the repository and you regenerate that hash, the hashes could be different. And that's how Git ensures data integrity across the repository and across the repository history. At any point in time, you can look at the entire repository and say, well, here's the hash for that repository at that time, and if anything has changed, then those hashes will be different, and you know that something isn't right. So that validation, that data integrity, is really important, and it's built into Git because of the way that it uses these hashes. And just as a side note, these hashes are actually used for everything. It's not just commits that are tracked by hash. Each file has its own hash. Each branch has its own hash. Everything is tracked via that hash. It is the unique identifier, the primary key for all of the entities in Git. So I'm talking about branches briefly, and again, this is kind of glazing over them. You're probably all familiar. We create a branch, get branch, hotfix, and then you check out the branch. When you check out a branch, what you're actually doing is switching your local head to the head of whatever branch it is that you're checking out. Some of you might be familiar, but just in case not, if you do git checkout with the -B option, you can actually do those two things in one step. So that creates the branch and checks it out in one step. Kind of nice. If you just do git branch, it'll list all your branches for you. The star, the asterisk there, represents the branch that you're currently on. Again, pretty familiar stuff probably. But there are some options for git branch that you might not be aware of. So we can do -- no merged. No merge just says only show me branches that aren't merged into, in this case, master, or whatever branch it is that you're merging into. So now we've got just the one branch. And if we were to do the -A option, you can see we see all of our branches, including our remote branches. Now we're going to talk about remotes at the end of the session, but what's important here to identify is that we've got 3 different remote branches: hotfix, master, and stuff. And you can see that those branches exist above, but we also have this other branch called other stuff, and you notice that it doesn't have a remote. So the -A option is really good for identifying, wait a second, what haven't I pushed up to GitHub, if that's your remote? What haven't I done yet? So it can be very helpful. The last thing about branches that I want to talk about right now is just differences. And we're going to get into changing things in the branches in a little bit, but I want to talk about the differences between branches. So let's say you've got this branch called stuff, and you want to see what's different between stuff and master. What is it that I've changed or that has been changed? You can see we just do git diff master and then stuff. And when you do it in that order, it is specific. What you're saying is what has happened in stuff that doesn't exist in master. And you can see there's a bunch of output there, but what you're really looking for is that +++, -, what it's saying there is, hey, there were some lines changed in the README file. And then directly after that, it shows you those changes. It says this is the README. Apparently that line did not exist previously and is new in the stuff branch. After that, you can see that we've also added a new file. So it says new file mode 100.644. That's actually 644 is actually the permissions on that file. So it's read write read read. So that file has been added in the stuff branch. You can also do this ... and ellipses in between the 2 branches. When you do the ellipses in between the 2 branches, what you're saying is, so going back on this step, what you're saying here is what's different between what's currently in master and what's currently in my stuff branch. When we do the ... what you're saying is take the stuff branch, which came off of the master branch, right? It branched at some point in the past. Now, master could have some changes in it since then. What I want, when you do the ... you're saying what's different in stuff between where stuff is now and where it branched from master, right? So you only want to see the differences between that common ancestry point, and not anything that might have happened in the meantime. This can be very helpful to just see what you've done in your branch. Really quickly, the branch names there, master and stuff, those are obviously names of branches, but all those really do is reference the head of each of those branches. Now, the head of the branch points to a specific commit. We're going to see this in just a little bit. But that, that commit hash you could also use in the diff. So if you had 2 specific commits within a branch that you needed to compare, you could just use the 2 hashes and see what changed between 2 commits very easily. I'm going to pause briefly and see if anyone has any questions, if you want to put them in the chat room. Also gives me time to drink some tea. All right. I'm going to press forward, and we're going to go into our next section, when things go wrong. And as we all know, things go wrong all the time. And there's lots of different ways that things can go wrong, and lots of different ways that you're going to need to correct them. And so we're going to go over a number of those things. First of all, are just really simple amendments. So amendments are to commits. So let's say you've committed something, and you realize, oh, that wasn't right. I need to change that commit. Here's the simplest example. You do a commit, and you say, this is to best. And you're not actually trying to be funny. You actually just misspelled that word, and you really don't want your boss to see that you can't spell. So you need to change this commit. And what we're going to do is we're going to amend the commit. And it's very easy. We just use git commit with the -- amend option. So you do -- amend, and then notice that we do the same nomenclature where we do the -m with quotes and the message, and we correct the message. And that's it. Once you do that, what you're telling it is go back to the previous commit, the one right before it, and change the message to what you have here in the second version. Now, it's important to understand that when you do this, you change the commit hashes. Remember, a commit hash is a hash of everything in the repository at that point in time. If you change the message, the hash necessarily has to change. There is no way for the hash to not change because the hash is different. So what you're seeing here, the bold lines there, that's the short version of the hash, the 7-byte version. And what you can see is that before we had FD0091E, and now we have 0486A7D. And so the commit hash has changed. And that's really important to note, because what that means is you should never commit, or you should never amend a commit if you've already pushed that to some remote. So if you're using GitHub or Bitbucket and you've committed something and then you've already pushed it up there and someone else may have already pulled that down, don't commit an amendment, because if you do, you're changing the commit history. And when you do that, it's going to cause a lot of problems for other people. Now, if you email your team, you're like, hey, has anyone pulled down the code? I just did a commit. No? Okay, I need to amend that, so don't do it until I finish the amendment. You know, maybe that's fine. If you're on a small team, that'll work. If you're on a big team, a distributed team, that can be really hairy, so be careful there. Just so you know, if you do the git log, you will only see the latest version. So you can see that it says this is the best, and so we have the corrected version in the git log. However, the reflog, which I'm going to talk more about a little bit later, actually shows everything. Notice we see the checkout of the branch, we see the first commit, and then we see the amended commit, and Git actually recognizes that as an amended commit. However, that reflog is only local to your system, so you don't need to really worry about this being visible everywhere. It's just important to understand that that history is tracked. And we're going to talk about the reflog in just a few minutes. So what if you forgot a file? This is really easy to do sometimes, where you've got 10 files that you're staging and committing, and you forgot the 11th. It just slipped your mind. It's really easy to fix this if you've just committed this. So you've just committed it, you realize things broke, you just add the file. So we add the file that was unstaged previously, and then you do a commit with -- amend. That's it. Now when you do this, Git is actually going to pop up a text editor, whatever your default text editor is, and it's going to ask you to enter a commit message. However, it's going to pre-fill that text editor with your commit message from the last commit, the one right before this. So it's saying, hey, I'm going to do a new commit. Do you want to update the message? And if you don't, if you just want to leave the message the same, that's great. You just save it. So now you've been able to add that forgotten file, amend the commit, but again, remember, this is going to change the commit hash, so you have to be very careful to understand that you're changing the Git history, and if anyone has pulled down that initial change, the incorrect one, then you're going to have problems. And in that case, you probably just need to do a new commit, if that's what happened. Okay, so let's talk about undoing changes. So in this case, we were just amending commits. Now we've done something wrong, and we need to fix it. We need to undo something. So let's start with unstaged changes. So you add a line to the README file. You add a line foobar to the README file, and you didn't actually want to do that. When we do git status, you can see that it says we're on branch master, and we've got this modified file README, and you can see that it's not staged for commit. There are no, it's only in your working directory. This is really easy. It actually tells you exactly how to fix it. Right there, it says use git checkout -- file to discard changes in the working directory. So very, very easy to fix. We just do git checkout readme.md, and when we do git status after that, you can see that there's nothing to commit. You're on branch master, and the working directory is clean. So that's a very simple way. If you have unstaged changes, just check out the file, and that clobbers whatever changes you've made. As a side note, you can actually do that for an entire directory. So if you've made changes across a few files, but you realize that that approach is not working, and you just want to clobber it and return to the branch head, then you can check out the entire directory and get rid of all those changes. But you need to be careful when you do that. If you have a new file, so let's say you changed a couple of files and you created a new file, and you realize it's not working, and you do git checkout source and you clobber all of those changes. New files that you created are not removed that way. It's not going to delete files. Git will never delete files in this manner, and so you need to actually manually remove that file. Otherwise, it would still be in your working directory, and Git would still think that you need to stage it. Okay, so new files you have to remove manually if they're unstaged and you're just trying to reset it. All right, now we get into the hard stuff. When you've already committed changes. So if you've already committed changes, or even if you've just staged changes, we need to use the reset command in Git. So let's look at what we've got. So we're going to start with this situation. We've got 3 versions of the same file. The blue, green, and red. The head of your repository of that branch, whatever branch you're on, is at version 3 on the right side of the screen in the red. Now your staging and your working directory, they're all pointing to the same thing. So all 3 areas of your your local Git repository are pointing to the same version of that file. But you realize that that version is incorrect. There's 3 different ways that we can kind of reset these changes and revert to some different stage. And I want to talk about that. So that's the git reset command. And the first version of that is the soft reset. So when you do git reset -- soft with the head and the caret sign, I'm going to go over the caret sign a little bit, but basically it just means go back 1 position. When you git reset soft, you can see, if I flip back to this one, see where the head is pointing? What we're doing is we're moving that head reference. So head, that all caps head, is just a reference in Git to the current edge of your branch. So whatever the furthest edge of your branch is, that's the head. When you git reset soft, you're moving that head back 1 position here to version 2. But notice that your staging and your working directory are still exactly the same. So what does that mean? Well, it means that after you do git reset soft and you do git status, Git is going to say, hey, you've got some changes staged. You have changes to be committed. That means they're staged and ready to go. So going back, you see we've moved the head, but our staging directory is now different from our head, and so Git thinks that we have stages to be committed. Now this might be what you want to do. Perhaps you need to reset and then stage some additional files and then do a separate commit. There's lots of different things that you might need to do here. But that's a soft just moves the head. So what about the other areas? So now we've got git reset mixed. When you do git reset mixed, you can see that the head reference still moves back to version 2, but our staging area also reverts to version 2. So now both of those things are version 2, but notice that our working directory is still at version 3. So after you do git reset mixed and you do git status, it'll say that you have changes that are not staged for commit. So these are only changes in your working directory. Right? Okay. So that's mixed. And then, of course, we've got reset hard. And a lot of people are familiar with this. This resets all 3 areas. So your head reference moves back to version 2, and both your staging and working directory are updated to match that point in time, that head reference. So now all of our areas are in sync, and if we were to do git status, you could see that we're on whatever our feature branch is, and we have nothing to commit. Right? Really quickly here, I do want to mention that in this diagram kind of alludes to it, but I didn't say it specifically. Notice that we've moved the head reference back from version 3 to version 2, but version 3 is still there. Right? Version 3 is still there, and in fact, if we were to do I'm actually going to get there, but when we do the reflog, you'll see that those versions are still there and we can still access them. Let's talk about this. So if we were doing a mixed reset like this, I wanted to point out that we can actually move that head position to a different place. So we did the caret. If we go back here, you can see we do head and then the caret symbol. That moves it back one position. From wherever the head is currently, move it back one from there. You can use the tilde and a number to move it back that many positions. So in this case, we're moving the head reference in our branch back 2 positions. And you can actually do a lot of different versions. So the caret sign is 1 back, but you can actually do multiple carets and it'll move it back, 1, 2, 3, whatever positions. You can use the tilde with an in or with a number, and that number is how many places back you want to move the head reference. And then you can actually use head at with the curly braces and a number to go to a reflog index. So what do I mean by a reflog index? Well, we saw the reflog earlier. Let's take another look at that. So if I were to do the git reflog after our reset here, what you're going to see is we've got some changes down at the bottom there, right? And then we've got a checkout to our new feature. We've got a commit that's a perfectly reasonable change. And then you've got another commit that is some nasty change that you don't really want. And now we do a reset, and notice it says moving to head caret. So the reflog is actually identifying that we moved back 1 position from the head. In this case, that means we moved to index 2. Notice where it says head at 2. So we moved back 1 from the nasty changes, back 1 commit to a new head position. And what's great here, and this is something that I really want to stress here, is that Git almost never removes information. It's very, very, very rare that Git removes information. It almost always adds information. So even though we've reset our branch, that commit that says added nasty changes, notice that there's a commit hash there, B49200C, that nasty changes commit. It still exists. And in fact, I can revert to that commit. So I could do git reset head at 1. Notice that the 1 index here is the nasty changes commit, right? So I can git reset head at 1, and it'll actually revert my reset. It'll undo my reset. Now, after doing that, notice that it says that I have unstaged changes after a reset. Why do I have unstaged changes after a reset? I moved to a different commit. Well, because previous to this command, I had removed those changes. So now I'm reintroducing those changes, which means I've got some unstaged changes from where my branch was. Basically, you just need to kind of kill whatever is there, and so we're just going to do a git checkout readme, and now we've got whatever that branch reference actually has. So this is those nasty changes. So you can actually do that, and you could do this at any point in time, right? We could say git reset head at 3 and revert both of those commits. So you can actually move around in the history very easily using git reset. All of these changes are identified in the reflog. All of that moving is in the reflog, but that reflog is local to you. Okay, so moving forward, my boss just told me to pivot. So a lot of times you've got a situation where you've made a bunch of changes, but those changes aren't ready to go yet, right? They're not atomic. You've made some changes, but you haven't quite finished that work, and now you need to pivot and go and do some other work. And the problem with this is you've got these changes, but you don't want to lose them. And what we don't want to have to do is just copy those changes off to your local file system and just put it on your desktop and then go do your stuff and then come back and reinsert them. That's really inefficient. That is what the stash is for. So let's assume that we've checked out some hotfix branch, and notice that when I do a git status, I get this unrelated file change. Like I've made this change, but this has nothing to do with the hotfix. I need to hold on to that change somewhere. So that's what the stash is for. So what we're going to do is we're going to stage our changes. So we've got this file called stashy. Now our stashy file is something that we don't want to come along for the ride. We don't want it to come over to that new branch. And so we're going to do git stash. And when we do that, it saves that work. Now, again, it only saves staged changes. So you have to stage your changes, but that's okay. You can always reset the staged changes. There's no, it's not actually in the repository. It's still only local to you. And when we do git stash, you can see that it's got the saved working directory and index state, blah, 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 right? So what's happened is we've removed those changes from our working directory. So now when I do git status, you can see that it says I'm on branch new feature, and I've got nothing to commit because those changes that I had, that new stashing file, is in our stash, not in our working directory. I can do git stash list, and when I do that, you can see that it has stash at 0, so 0 is the index. So it says stash at 0 is a work in progress, WIP, work in progress on new feature branch, and it says this is the best. So what does that mean? What it's saying is you stash some changes, and the commit right before that was called was 3C927DD, and the commit message was this is the best. So that's the commit that happened right before all of the work that you stashed. Now that's okay, but that's not terribly helpful. It doesn't really tell you what you were working on. It tells you what had already been done. And so we have this nice feature called the save command with stash, so we can do git stash save, and then in quotes you can pass in a message. And now when you do your git stash list, you can see that it's the same thing, stash at 0. It tells you what branch that was on, but it also gives that custom message instead of the previous commit message. So it's a lot easier to track, especially if you have multiple things in your stash. So you can have multiple entries in there, right? So this is stash 0, but then I can do some other work, stash those changes, do some other work, stash those changes, and all of those changes can be given a message so that you know exactly what they were for. If you don't do that, it can be very confusing to know what you're trying to pull back out. So we've got the stash, but now we need to get things out of the stash, right? So git stash apply is how we do that. That's one way that we do that. So when you do git stash apply, it takes everything in the 0 index, the top index of the stash, and it takes all those changes and it applies them to wherever you are. So if you're in this new feature branch, or if you're in master, or wherever you are, it's going to apply those changes to that work. So it's going to add this new stashy file to your working directory. Now notice that when I do git stash list, that stash entry is still there. So nothing has changed in the stash still exists. Git stash apply just takes those changes and applies them to your current working directory. We can also do git stash pop. Git stash pop is very similar to apply. It applies the changes, but it also drops that reference. So it applies the changes and removes that stash entry, because the assumption is here you don't need anymore. So if I do git stash list, you can see that it's empty. There's nothing in there. Now, if you were to apply some changes, and then you needed to, at some later point in time, drop those changes, it's easy. We just do git stash drop with stash at and then the index. So if you had 3 entries and you needed to remove the index number 2, then you can just do git stash drop, stash at, git stash drop, stash at, curly braces 2. I was going to pause here for questions anyway. So how do you revert the file back to your working directory? So when you do git stash pop or git stash apply, you are adding that file to your working directory. This is the process of adding the file to your working directory. Now, in this case, you can see that because all of the files that are changed in the stash are staged, when we apply those changes, we get changes to be committed. So stashy is actually a change to be committed, is in our staging area. Now, if we didn't want that, if you didn't want that file to be in the staging area and you just wanted it in your working directory, you can see git actually tells you right there, it says git reset head, and so you can git reset head and that will unstage this particular change. Drew, I see that you have another question without adding it to the head tree. I'm not sure exactly what you're referring to there. When you revert the file back to, this is reverting the file from the stash into your working directory and to your staging area. If you wanted to undo those changes, you could just reset them. If you need to put them back in the stash, obviously you could just do git stash again. All right, so any other questions in chat for stashing or amending changes, things like that? More tea. All right, let's move on to logs and blame. The git log is very useful. I would highly encourage you to explore it. And a lot of people have done git log, but a lot of people don't understand all of the different options that we can have. So when you do git log, this is the output you get, and it's actually pretty bulky. It's a lot of information, which is great, but it's kind of bulky. Most of the time, when I'm looking at the git log, I just want really succinct things. So I usually go for the one-line option. So -- one line shows you the 7-byte hash and the message, and it's only the first, I think, 72 bytes of the message. It's not a whole lot. And now you can just get the quick overview and kind of scan it and see what you're looking for. I have one other question that I'll go ahead and answer. Is the stash list per repo or per branch? It's per repo. However, each stash entry does reference what branch it came from. Because remember, the files were staged to that branch. There's another option called -- graph. Now, a lot of you, if you're using GUI tools, probably can get a graph in your GUI tool, and that's all great and dandy. But why wouldn't you want this nice textual graph? So what we've got here is we're doing the one-line option and -- graph. When you do both of those, you get a nice little succinct graph here. So at the bottom, you have some common ancestor, and you can see there's a commit with the short commit message, and then those two lines coming out of it show a branch. And it says, okay, we did another commit on some other branch, that's the asterisk, and then we branched again. And then we did some work in both of those branches. And then you can see we got the 3E3A8FD, and it says merge branch. So you can see the lines coming back together, and that was where one branch was merged, and then after that we've got another merged branch. And so you can actually see pretty easily, if you have good processes in place for your branching and merging, you can see a pretty succinct, simple graph without having to use those GUI tools. I don't know if you can tell, I'm not a big fan of the GUI tools. So a couple other options I just want to kind of glance over. The no merges, this is kind of similar to seeing all of your branches that are unmerged, but what this is showing you is hide all of the merge commits. So this won't, so if you look back here, we've got those merge commits that say merge branch whatever, merge pull request whatever. This just hides all those merges, so it will only show the things that are not merged. You can restrict by author, you can restrict by date, so you can say only show me commits before a certain date. But there's a bunch of other ones, so I'd encourage you to look through those. Since, after, until, query, all sorts of different things that you can look through. You can, in fact, what I really like here is the git log with the -- and then a path. That'll only show you commits that have changes in that path. So very helpful when you just want to have commits where your CSS is changed, or your JavaScript, or whatever. So I want to talk about pointing blame in the log, and specifically the fact that it could very possibly be write it yourself. So be careful. Git blame is a nice little tool, but a lot of times you're going to be blaming yourself. So let's say I've got a nice little JavaScript utility function here that sums two variables x and y and returns, supposedly returns the sum. When I do git blame on that file, what you're seeing here is the commit hash and the person who committed it and the date, along with all of the lines of that file. And if you notice on line 4, it looks like we're actually returning x times y, not x plus y. And it looks like Ryan made that change. So what you're able to see here is on each line, just the last commit. Who is the last person to touch that specific line? And so that can be really helpful for pointing out when you know where something has gone wrong and when it went wrong, you can very easily identify that. You can also restrict this by lines. So at the very top, you can see I've got L3, 5. And so I can restrict the git blame to just those lines if I need to focus. Now, obviously, when you have bigger files, you really do need to focus on a particular function or something. So what about when you don't know when things went bad? And that's really a big problem, is when you don't know when they went bad. That's what git bisect is for. Now, I don't use git bisect very often, but when you need to use it, it's good to know how. First of all, I want to point out that git bisect doesn't give you a lot of good feedback. So you really have to know how to use it, because you might do something like this, git bisect start, because that's how you know to start it. And then it does nothing. Git doesn't tell you anything. It doesn't say what to do next. So what you're going to do is you're going to do git bisect start. And at this point, you're starting a bisect session. You say git bisect start, and then you have to tell Git what the bad commit is. Where do you know that things are wrong? And if you know things are wrong right now, you can just say git bisect bad, and it'll take the current head and it will say, okay, this is the bad one. But you could also specify a particular commit like you've got in that lower portion. So once you do that, you need to then also specify a good point in time. So you have to go back and you say, this commit is good. So what you're saying is, on one end I've got a bad commit, and on the other end I've got a good commit. And somewhere in there things went wrong. And what Git is telling us now, after specifying the first good, or the last goods position, it's saying, okay, we've got 3 revisions left and about 2 steps, and we're going to find this problem. So now what it says is, I've checked out this commit, 7E3F939, blah, 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 right? So it checks out that commit for you. And then you have to tell it whether that's good or bad. So you either do git bisect good or you do git bisect bad. Either one, Git is going to record that entry, and then it's going to check out a different commit for you. And then you're going to tell it whether that one was good or bad. And in this manner, Git is bisecting your repository commit history and coming down eventually to narrow in on where the first bad commit was. So then when at some point, Git is going to say, this hash is the first bad commit, and it tells you the git log entry. And now you know that's what happened, that's the person that's at fault, and so now you can narrow in and figure out what changed in that commit and then do whatever you need to do to fix it. When you do git bisect, it removes you from the branch you're on. So this is kind of an important note. You're no longer on a specific branch, and because of that, you have to then do a git bisect reset in order to return you to a branch. Pretty easy. All right, we've got a lot to go through still, so I'm going to kind of blaze through a little bit of this. Playing nice with others. So this is merging and rebasing. When you have no divergent changes from your branch in the source, so you've got a master and you've got your branch, and nothing has happened in master since you've changed, that's easy, that's fast forward. Now, you don't have to do fast forwards, but I actually like them just fine. So you have people on different opinions, but this is when you can use a fast forward, is when you have no changes. So we've got master, we've got the feature branch, and all we're going to do is pop that one commit right on top of the other one, and then move the master branch, the master reference up. So that's it. It just fast forwards the master reference up. More likely, you're going to have something like this, where you've got a new branch called feature, and you've done some changes there, and you have your master branch that has had some other changes in the meantime, right? That's the purple change. And now we need to figure out how to merge those. And this is what happens. What we do is we actually create a merge commit. So the green one on the right side is a merging between the purple and the red. So it's taking the purple and the red, and it's creating a merge that is everything that needs to be kind of worked out between the two. Now, after that happens, the master reference can just be fast forwarded up to that new commit. So that green commit is the merge commit, and the red commit is now in your git log, right? So it's in the git log. It looks like one line, but we've got this new commit that was created. A lot of people don't like merge commits because they think that it muddles up the history. I say it shows you very clearly when a merge happened. So I actually kind of like them. It's also important to note that merge commits are the only type of commit that has 2 parents. Notice here that green commit on the right side actually has 2 lines coming out of it in the back that point to the 2 commits that it came from. Every other commit only has 1 parent. That's how Git knows that that is a merge commit. So of course, a lot of times you can't simply automatically merge things. A lot of times you have conflicts. When you have a conflict, it very clearly tells you, hey, I couldn't auto-merge readme.md. I've got a conflict. It's easy. You just open up the README file, and it's going to show you that you've got changes in the head and changes in the branch. You just fix up those changes, and then you stage the file, commit the file with a merge message, and you need to remove this orig file. The orig file is what was in the branch before you started the conflict resolution. All right, rebasing. Now, a lot of people like and a lot of people dislike rebasing. I am not really a fan, but that's neither here nor there. I'm going to show you what it is. Here's one key thing to remember, though. You should never rebase commits that you've already pushed to a remote repository. So you've already pushed things to GitHub. You should not rebase. Why? because rebasing rewrites the history. It rewrites your commit history, and because of that, you're going to have problems if someone else has already pulled down those commits before you're rebasing. So this is what it's going to kind of look like. We've got basically the same setup as a merge, right, where we've got some divergent changes in master. And when you do git rebase master, what's going to happen is Git is actually going to create a new commit that is the changes between the common ancestor, C1, and our former red C2. And it's going to create a new commit for the changes between C2 and C4. So it's basically creating new commits that line up with what was already happening in master. So it kind of moves those up, does that merging in new commits that it then rewrites the history of your branch for, and then it can just apply those commits directly onto the master branch and pull the master reference forward. Notice that those old commits still exist. They're still in the Git history, but they're not actually part of the history of that branch. That branch's history has changed. So again, if you have changes in conflicts, you can still have those. I'm sorry, if you have changes that you've already pushed to GitHub or something, you don't want to rebase because someone could have already pulled down those changes, and now their history is going to be all messed up. Really quick, you can still get conflicts. Conflicts are basically resolved the same way. They look a little bit different. It says you got a patch failure because that's how rebase works. It does patches. The steps are the same though. You fix the conflict, you stage the file, but then instead of committing, you do git rebase continue. You can also skip an entire commit if you've got a conflict. It's probably not a good idea. I mentioned it here so that you know that it's there, but you probably should not do that. And the last thing is an abort. If you're doing a rebase and you realize this is not going well, you can do git rebase -- abort, and you just throw away whatever you were doing and you revert back to the branch that you're on. Final reminder, do not rebase commits that you've already pushed to a remote. You're going to have a lot of problems. People are not going to like you. Cherry picking, really easy, moving commits from one place to another. So here we've got two different branches, new feature and old feature, and we want to move that red commit up to new feature. So we do git checkout new feature, and then we cherry pick with the commit hash, and now we've moved that commit up. And when we do that, we can now delete the old feature without any concern because we've now got that new commit. Or I'm sorry, we moved that commit to the new branch. But notice that that new commit has a new hash. Before it was D42C3 whatever, and now it's ABC123. So that commit is actually a completely new hash. It's a new commit. It just has these same changes that the old commit had. You can actually still have conflicts when you do cherry pick because it might be applying those changes on top of other changes. You should really only be doing cherry pick if you're not going to use that branch because it's changing the commit history. Tagging, super easy. It's just really a labeling mechanism. That's really all it is. So you're on a particular branch, you do git tag version whatever, and when you do that, you've now got potentially all of these different tags. All of these tags are just pointers to a specific commit. So if I do git show with version 1, it's going to show me the commit that that tag points to. That's all it is. Git tags are just labels. They're labels for particular commit hashes. If I were to check out this tag, you can see that I now am in a detached head state. What that means is it checked out that commit for me, and that's great, but it can't really do anything with that because I'm not on a branch. But what you can do is create a new branch from that point in time, basically spur it off, and then do your changes, commit that new branch, and there you go. So I have -4 minutes to cover remotes and upstreams. So I just want to talk about them real quick. When you do a clone, what you're basically doing is saying, hey, create me this repository and automatically create a remote called origin. Notice that when I do git branch -a, I've got master and remotes /origin/master. So the origin is the name of the remote. Real quick, are tags numbers auto-generated? No, you're specifying that number, or it's not a number. You could call it whatever you want. You could call it foobar. Git branch -vv, very helpful. What this is going to do is it's going to show you your branch, master, and in the square brackets, it shows you what remote that local branch is tracking. Basically, if I were to push to master, what remote is it going to go to? In this case, it's origin/master. Pushing is, just mentioned that, git push master. You're probably already pretty familiar with that. If you create a new branch, that branch, new feature, you can see is not actually in my remotes. So when I do git branch-a, I've got master, new feature, and then one remote, but not the other one. To add tracking for a local branch, it's really easy. You do git push -u. So you're saying you're specifying the upstream is going to be origin for that new feature. So this pushes that new branch to GitHub, for example, and creates that remote tracking. Git remote-v will show you the actual URLs for those, so that's kind of nice. And I don't really have time for this, but really briefly, the open source Git model. So this is just kind of generally the process flow. You fork a project on GitHub, Bitbucket, whatever. You clone it locally, just like you saw earlier. You make some changes. You push those changes to your remote fork, just like we showed you, where is it? Here. You just push that new branch to your remote. And then you submit the pull request. If you've got some changes in the pull request, then you need to add a new upstream. Remember, origin was our original upstream. We need to add a new upstream, a new remote we're going to call upstream that is jQuery, if in this particular case. And then we can see now we've got two remotes, and what you're going to do is fetch those upstream changes. I know this is kind of a whirlwind, so I would encourage you to go back and look at these slides, because it's going to be a lot more clear if you just kind of go through those. So when we fetch that upstream, we get those changes, and then we can check out our master branch and pull those changes into our local repository from that remote upstream of the jQuery core. All right, so what's next? You do your pull request, and honestly, you're going to do those through GitHub and Bitbucket. There is a native functionality for that. Don't use it, I promise. It's better to just use GitHub, Bitbucket, TFS, whatever you're using. Use their pull request mechanism. It's going to be much easier. That's all I have for you. This has been Getting Git. I'm Jordan Kasper. You got my Twitter handle up there, and the link to those slides. I believe someone put it in the chat, but I will go ahead and drop it in here again. Feel free to hit me up on Twitter or if you have any questions about the material. And we've got 3 minutes, so any questions in the chat? What is my favorite feature of Git over Subversion? It is probably... It's probably the merging process. The merging process in Subversion is really, really hairy for me, and I really appreciate the history and the tracking that Git has for merging and just the branching strategy in general. Do I recommend using Tortoise Git? Any of those tools are just fine if you're using a GUI tool. Tortoise is kind of nice because it integrates with your native file system, so if you're on Windows File Explorer, if you're on Linux, Nautilus. And that can be kind of nice because you can see like little green checkboxes in your folders and stuff like that. And that can be really nice. I still use the command line for all of my actual work with Git, but having those icons in the folders can be really helpful.